we're going to go through and I'm going to do some extra problems for those that are either absent or maybe those in class that just want to hear it one more time. So what I did is I cut and paste some of the questions that we did in class together today over Taylor Polynomials so that you got a chance to watch it and kind of hear me talk through it. So the idea is a Taylor polynomial is something that is used to approximate a more complex function with a polynomial function. So for example, you'll see a lot of things that are exponential, like e to the x is really common, sine, cosine, natural log, things that are rational that have something in the denominator, things that have radicals like square roots. And the idea is if we can write a polynomial-based function that will approximate this more complex function, it will give us a great approximation around we call the center of the polynomial. Now at the center, and we often center around 0, those are called Maclaurin polynomials, or 1. We sometimes do 2, like this one you're looking at on the screen is centered at 1. The approximation will actually be perfect at the center. It will be really good close to the center, and then the further out you get from the center, the less accurate it is. And I loved on Delta Math that it actually showed a picture of that, so you could see how close together the original function and the Taylor polynomial are at that center, and then how as you go further away from it, it weakens and becomes a very different looking graph. So I'm going to take you through, this one is one that was on an old worksheet that I used, but then I'm also going to take you through some multiple choice questions that I've found either from old AP tests or from the Barron's book, and just kind of give you an idea of what could be asked and what the expectation is of you. So with this one, we have a function 1 over x, a rational function. And we're being asked to write the n. So when n equals 4, that's telling you the degree of the polynomial. So that's saying that we are doing, a lot of times we write it like this, a 4th degree polynomial. And then my center value, sometimes they'll just say it in words or they'll write c equals is 1. So the first thing I need to do is I need to take 4 derivatives. So my first derivative of 1 over x is going to be negative 1 over x squared. So when I'm deriving this, I have to think of 1 over x as like x to the negative 1. So I'm doing power out front, power 1 less, and just continuing that. My second derivative is going to be power out front, power 1 less, 2 over x to the third. And then my third derivative is going to be negative 6 over x to the fourth. And then my fourth derivative, so once we go higher than 3, we start writing the derivative in like parentheses. So we have 24 over x to the fifth. And then the next thing I like to do is just kind of go through and plug the center in to the original and to all the derivatives, because those are going to be your coefficients that you're going to use. So when I put 1 into the original, I get 1. And then when I put it into this one, I'm going to get negative 1. And then I'm going to get 2. And then I'm going to get negative 6. And then I'm going to get 24. So the way we write our polynomials, we start with our constant term, 1. And then we take our next term, in this case, negative 1. You're going to take x minus the center. If you're centered at 0, you're just going to have an x to the first power over 1 factorial, which is just going to be x minus 1. First power, 1 factorial is not going to change anything. And then the next coefficient, so plus 2, now it's going to be x minus 1 to the second power, and it's going to be over 2 factorial. Then the next one is going to be a minus 6. It's going to be x minus 1 to the third power over 3 factorial. And then finally, 24, x minus 1 to the fourth power over 4 factorial. As far as simplifying, I don't know on Delta Math if they require simplifying. I do try to do it, especially if it's obvious. I don't always do it. On a test, if you don't simplify and it marks it wrong, I'll go back and give you the points. On the AP test, they do tend to, with multiple choice, leave simplified answers. So it is kind of helpful to be able to compare. Like, for example, in this one, everything that's coefficient will cancel. 2 over 2 factorial is just 1. 3 factorial is just 6. So 6 over 3 factorial cancels. 24 is the same as 4 factorial. So you could actually get this pretty reduced down. Another thing that you might see done on like a test, I think I put a question like this on my quiz, is sometimes they will ask to use this polynomial that you just wrote to make an approximation. For example, they say, well, now make an approximation using this 4th degree polynomial at 1.1. They're going to have to ask you to make an approximation that's close to the center. So, anything as we get further away from the center would be so weak they wouldn't ask that. So that's another question you might see asked. Sometimes they will just ask about certain terms. Sometimes it's matching in like a multiple choice setting, and sometimes it's just writing out a certain degree polynomial. When they do say degree polynomial, they are referring to the power. So that tells you the highest power of your last term. So I have some questions that came from the Barron's book. So you can kind of see these were cut and paste, tells you kind of where I found them. Just giving you an idea of things that they'll ask. So this is a very specific one. They give you a function. They ask you to do the Taylor polynomial of degree 3. It is centered at 0, which is nice, easier to work with. So when I take the derivative here, I am going to have to do a chain rule. So I'm going to just kind of make my derivatives off to the side here. So power out front is 1/2. Power 1 less is to the negative 1/2. Then when I take a second derivative, power out front is going to be negative 1/4. Power 1 less is going to be negative 3/2. I'm actually not going to simplify right now just because it's easier for me to keep deriving if I keep that exponent written like that. Then I'm going to do power out front, power 1 less again. So now I'm going to get positive 3/8. 1 plus x to the negative 5/2. And I'm done. I've gone 3 derivatives. So when I put 0 into my original, I get 1. So when I do questions like this, I kind of give you a view into how my brain processes it. I like to think of it as like process of elimination. So as soon as you find a term, look at your choices and see if they all have that. If they do, keep going to the next term. And eventually you're going to get to a point where you're only going to have one that has matched everything. So my first term is 1, which they all have. So that doesn't really help me much. Now when I put a 0 into this one, I'm going to get 1/2. When I put 0 into this parentheses, I'm just going to get 1 to any power is 1. So I'm going to get 1/2. So my next term should have a coefficient of 1/2. It should be x to the first over 1 factorial. It is positive. So I am crossing off this one because this next term should be positive. Then I'm going to go to the next one. When I put 0 in for that, I'm going to get negative 1/4. So if I have a negative 1/4, I'm going to come off to the side, x to the second over 2 factorial. That's going to give me a negative 1/8 x squared. So that's going to get rid of this one because it has the wrong denominator here. So now I'm going to go to my last derivative. When I put 0 in, I'm going to get 3/8. So I'm going to have 3/8 x to the third over 3 factorial. So that's 3x to the third over 8 times 6, 3 factorial 6. That will reduce to 1/2. So we get x to the third over 16. And looking at the two choices I have left, the only one that has all of the right terms is B. That is the best way to do a question like this, is just every time you find a term of your polynomial, double check, because usually it will take off one of your options and you'll have one choice left remaining. So the last couple I have are very generic ways to write it. I actually kind of like the generic ones. So this one says that we have a Taylor polynomial of degree 3. We are centered at 0 again. And they're writing the function as 1 plus x to the p, where p is just some constant power. So when I derive, if you think about your derivative process, the first time I derive, I'm going to get power out front, power 1 less, which is going to be p minus 1. Then when I derive again, I'm going to get p. I'm going to do power out front, so the p minus 1 is going to come out front, and then 1 plus x to the p minus 2. Then when I derive again, I'm going to have the p minus 1. I'm going to bring power out front again, and then power 1 less. So when I put 0 in, my coefficients for my first one, when I put 0 in, is just 1. That actually does get rid of d. D does not have the first term, right? It should have a 1 first. Doesn't have that. So my next one, when I put 1 in, is just going to be p and times x, which all of them have, so that didn't help me much. Then when I put in 1 for the next one, I'm going to get p minus 1. It is going to be times x squared, and it is going to be divided by 2 factorial, which is not the case in choice A because it doesn't divide by 2. Still good so far with B and C. My next one is going to be p minus 1, p minus 2. X is going to be to the third power, and you're going to divide by 3 factorial. And we finally found the other issue. This one does not have the factorial, so my correct answer there is C. And then finally this one also came from the Barron's book, so sorry it's not super neat, but at least gives you a little insight into what we talked about in class. I like questions like this. You will see a question like this on your upcoming quiz, which we're looking at like middle of next week, where instead of giving you a function that you have to derive and plug in over and over again, they just tell you what you get when you plug into this generic function. So this is saying I'm working with this function h that has all these derivatives at x equals 1, and it actually tells us that h of 1, h prime of 1, h double prime of 1, and h triple prime of 1 all equal 6. Sometimes they'll list them separate. We looked at one in class today where the first derivative was maybe 5 and the second derivative was 3 and the third derivative was 4, but they're giving you that extra information and saving you a lot of time. It wants to know which would be the third degree polynomial that would approximate it. Well, first thing, when you look at these 4 choices, there are 2 that you should cross out right away. We are looking at centered around 1. So because we are trying to approximate h at 1, so we need to have x minus 1 happening, and that is not happening in A, and it is not happening in C. So right away, I'm down to 50-50. So my first term is 6. My next term is going to be 6 times x minus 1, which both are still good. My next one is going to be 6 times x minus 1 to the second power over 2 factorial. And you can see right there, b forgets to divide by the factorial. It still has the coefficient of 6. It actually has the same problem with the last term in that as well. So the correct one here is D. So that gives you not only an idea of kind of what we did, there is a Delta Math assignment that you will need to complete as well, but I wanted you to be able to hear some of our examples we did in class to help you with the different ways problems can be presented.